Law enforcement agencies were the earliest adopters of fingerprint identification technology, though in the mid to late 19th century, a theorist of heredity named Francis Galton believed that fingerprints could serve as an external proof of inherited criminality. Galton quickly learned that fingerprints did not reveal criminal tendencies, but saw the importance of continuing his research and dedicated the next 10 years to promoting this system of fingerprint identification and surveillance. Police departments in the United States and Europe began adopting this identification method by the turn of the century, with the New York City Police Department being the first in the U.S. to adopt this technology in 1904. All officers were trained in the methods of taking prints, but only a few were learned enough to decipher them.
There are people specifically who would read the fingerprints and verify that one fingerprint was exactly the same as the next one, even as far as comparing it to crime scene fingerprints. And there are people specifically trained just to do that. It used to take forever. Even getting the response back once the fingerprints were taken would take a considerable amount of time. Whereas today it's virtually within minutes. You could identify who you have standing in front of you.
Fingerprinting draws heavily from the science of dactyloscopy, which examines how we are capable of retrieving prints. The inside surfaces of the hands, from the fingertips to the wrists, contain minute ridges of skin. These ridges have pores along their entire length that exude perspiration. When an article is picked up, the perspiration runs along the ridges and leaves an exact impression, just as an inked rubber stamp leaves an impression on a blank sheet of paper. There are 3 different types of fingerprints that can be analyzed: latent prints, plastic prints, and patent prints. Latent prints are those left by the moisture formed in a person's hands, not visible to the naked eye. Plastic prints are impressions left in clay, tar, or paint. And patent prints are the visible prints left in a substance such as blood or oil.
For a prosecutor who's trying to build a case based upon the evidence, the latent fingerprint is really the bread and butter type of fingerprint. That's left by a burglar or a robber or even a murderer who touches something at the scene of the crime, leaving that latent print inadvertently. The fingerprint expert can, by applying powder and gases and other media, can make that print visible, can actually lift it, photograph it, and then compare it to the known fingerprints of people and hopefully make an identification.
The patterns left by these ridges form 4 basic types: the arch, the tent, the loop, and the whorl. This minor classification was a major step forwards in the use of fingerprints. It enabled forms bearing prints ranging from arch patterns to patterns left by bodily scarring to be placed in a certain order, making the search for a specific person a whole lot easier.
Really, it's in the technique. It's you need to get a very good, clear print, but the machine tells you that. If the print is no good, it tells you to rescan it. So it eliminated all of the guesswork. It gives you an opportunity to change, what could be problematic down the road.
The heart of the optical scanner is a charged coupled device, or CCD, the same light sensor system used in digital cameras and camcorders. The scanning process starts when you place your finger on a glass plate and a CCD camera takes a picture. Before comparing the print to stored data, the scanner processor makes sure the CCD has captured a clear image. If the processor finds that the image is crisp and properly exposed, it proceeds to comparing the captured fingerprint with fingerprints on file. But no matter how advanced this machine seems to get, its legitimacy is still questioned in our legal system.
There's been a significant challenge in the last 5 or 10 years by defense attorneys to the science of fingerprinting. And their argument is that it is not scientific and it should not be allowed into court. You can't just introduce a computer-generated match in court, at least not in a criminal case. You need an actual expert witness to come in, say, I personally observed these two, I did all my calculations, and in my opinion, it could only be from this particular person.
People are now questioning the statistics behind the fingerprints. Is a fingerprint truly unique to that person to the exclusion of all others? DNA might be more prevalent these days than actually fingerprints. Because DNA was developed out of the forensic science field, more in the biological field, you can give frequency numbers with DNA samples. So you can come into court and you can say the likelihood of this sample matching the defendant is 1 in 10 million. Or the likelihood of it matching somebody else and not the defendant would be 1 in 10 million. In the rest of the forensic world, we normally never gave frequencies. In the trace world, for instance, in hairs and fibers and footwear and tire tracks and those kind of areas, we just say typically the conclusion might be it could have come from that person.
DNA is virtually foolproof. If you get a decent DNA sample and a match to a known person, it's very, very difficult to contest that evidence. I think we're just at the beginning of knowing what science is capable of.